Hey everyone, today we'll be solving LeetCode problem number 201, bitwise and of number range. In this problem, we are given a number range from left to right inclusively. And what we have to do is we have to take the AND of all of this number in this range. Let's say if in an example we are given range from left to right as 5 to 7. So we have to take AND of all the numbers in this range and we have to return the result. So how we are going to do that? If we go with the brute force approach, so we are going to take AND of 5 to 6 with 7 in the range from left to right. So what will be the answer here? What is the binary form of 5? 4 and 1. This is the binary form of 5. What about 6? 4 plus 2, 6. What about 7? 4, 5, 6 and 7. And now if I take AND of all of these values, so what is AND operator? If two values are 1, only in that case it is 1. If any one of the value is 0, let's say if it 1 and 0 and 1 and 1, it is 0. All should be on to make the final output as on. So if I take the AND operator here manually, what will be the answer? This is 1, this is 1, this is 0. So on the rightmost side it is 0. This is 0, this is 1, 1. So ultimately it is 0. And here we have 1, 1, 1. So it will be 1, 0, 0. So this is our answer, which is 4. This we have to return. Like in the example, for the value as an input 5 to 7, we have 4 our answer. But here if we follow this approach and if we have a look at the constraints, so constraints are from 0 to 2 raised to power 32, or you can say 31 minus 1. So it's a very high range. So if we are going to do this way, so we will be going from 0, 1, 2 to 3, 4, 5, 6 till 2 raised to power 31 minus 1. So it's a huge time, and the time complexity is order of n. The n is the range and the n value is too large. So over the small cases like range from 5 to 7, it is going to submit the answer. But on the larger values, we are going to get TLE if we are following this approach, that is going from left to right. So now how do we improve it further? Now let's have a look on our optimized approach. Here the left value is 5 and the right value of range is 7. If I do the binary representation, it is 4 plus 1, 5, 4 plus 2, 6 and 7, 4, 5, 6, 7. So this is 5, this is 6, this is 7, and this is our left value, this is our right value. Here we can see that in these values we have a difference of 1. So on the rightmost side we are going to get at least 1 0. If you are not able to get any 0, it means that this is not a series. So on the righter side we are going to get at least 1 0. If there is at least 1 0, it means in the resultant we are definitely going to get 0. Similar for the second last column, if we are having at least 1 0, we will get 0 in our answer. So what is the trick here? The trick here is that we have to figure out the common prefix. We have to get the common prefix of all of these binary representations. So for this common prefix, how do we do? We have to some way get rid of these values. And our left is 5 in the starting, right is 7 in the starting. So if I do the right shift, will I be able to achieve this common prefix? Yeah, right. If I'm doing one right shift, it means I'm discarding first column. If I'm doing the one right shift again, I'm discarding one column. After right shifting 2 times. For this example, our left and the right value are becoming equal. So what if I do the right shift, 2 right shift on all the values? It will be 1, 1, 1. These two will be gone, these two will be gone, these two will be gone. So all of these values are 1, 1, 1. It means that left value and the right value is now equal. So what we are going to do is, while left is less than R, we will keep on doing the right shift. Left, right shift by 1, right shift by 1. Okay, now we are able to achieve the prefix. So now, but this is the prefix, not the answer. Answer, it means the AND of all of these values. So what is the AND of all of these value? All of the rightmost value where the column is having at least 1 0 is going to be 0, and the first column which is making this prefix value will be 1. If there is no prefix, it is going to be 0. All of these value are 1. So for the first prefix, we have this. This is our prefix after making 2 right shifts. So to get our answer or get our AND value, we will make these left shift again. So over the 1, which is our prefix, I will make left shift 2 times, because 2 times we were making right shift to get the prefix. So we will keep track of the shifts plus plus. So once we are doing this is our step 1. Step 1 is done. It means we are able to achieve this prefix value. And what is our prefix value? This L value and R value, all of these value are our prefix. So on any one of these value, let's say I'm taking left. If I make the left shift by shift number of time, this is going to be my AND value, and I can return this from this function. So this was our optimized approach. I hope you got the steps what I'm doing. The main trick is that we have to find the common prefix. If you are not able to understand this or finding it difficult to understand, you can just try it on a couple of examples. Let's also discuss the time and space complexity here. So what is the time complexity? In the previous approach, in a brute force, we were iterating from left to right. So it was going order of n. So here we are not iterating over our whole range. We are just evaluating left and right and making the right shift in the starting, and in the end we are doing the left shift. So in the integer, it is already fixed that we have 32 bits. So in the worst case, it can be order of 32. It means that it is a constant time solution. So the time complexity is order of 1. And what is the space complexity? Space complexity is also order of 1. So it's a constant time solution always, whatever the value of range. Now let's quickly code this problem.